Another gas law that can be useful when you're dealing with mixtures of gases is Dalton's law of partial pressures. And what Dalton's law says is that the total pressure of a system that contains a mixture of gases is equal to the sum of the individual or partial pressures of each of the gases that are in that mixture. Now, the gas laws, like the ideal gas law, can be used for pure gases as well as mixtures of gases. Gases always are homogeneous mixtures, which means they mix uniformly because compared to the size of the gas molecules, there's large amounts of space, so the gas molecules mix freely. So Dalton's law can be used when you have more than one gas in a mixture. You could also use the ideal gas law and Dalton's law together because the ideal gas law would work for a mixture just as well. So I wanted to give you an example of Dalton's law of partial pressures by doing 10.81. In this problem it says a mixture of gases contains 315 torr of nitrogen, 275 torr of oxygen, and 285 torr of argon. The question is, what is the total pressure? Well, what Dalton's law says is that we can add up all of these gases to determine the total pressure of that mixture. So, the total pressure of this mixture is 875 torr. And we get that simply by adding up the sums of the partial pressures of each gas in the mixture. Now the second part of this asks what the mole fraction of O2 is. Well, pressure if you're at the same volume and temperature, pressure is proportional to the amount or the number of moles. So to determine the mole fraction of a gas, we can use the pressures. So if we're looking at oxygen, so we would be looking at this one right here. We would take the partial pressure of oxygen, which is 275 torr, divided by the total pressure of the whole sample, and that would give us our fraction of 0.314. So this is the mole fraction of oxygen. Now this only asks for oxygen, but you could get the mole fraction of each component in the mixture by dividing the partial pressure of that gas by the total pressure of the mixture.